This is another example of discrete time Fourier series composition of a cosine function. We have x equals to cosine 2 pi over 8, and you can clearly see that the capital N is repeated every 8 times. We can write this x equals to cosine pi n over 4 as e to the power of j pi n over 4 plus e to the power of negative j pi n over 4. Since cosine pi n over 4 can be represented by e to the power of j pi n over 4 plus e to the power of negative j pi n over 4, we can also see that the discrete time Fourier series of cosine pi n over 4 is the sum of the discrete time Fourier series of these two functions themselves. So here we have discrete time Fourier series cosine pi n over 4 equals to discrete time Fourier series of e to the power of j pi n over 4 plus discrete time Fourier series of e to the power of negative j pi n over 4. Discrete time Fourier series of e to the power of j pi n over 4 has a single impulse at n equals to 1, at ck equals to 8. Similarly, we get into discrete time Fourier series of e to the power of negative j pi n over 4. In a funeral, we have the inner product of xn equals to e to the power of j pi n over 4 and an exponential series of e to the power of negative j pi n over 4k, where k denotes the numbers of harmonics. We have ck equals to summation of e to the power of negative j pi n over 4 times e to the power of negative j pi n over 4 from 0 to 7 equals to the summation of e to the power of negative j pi n over 4 times 1 plus k. For k equals to 7, we get 1 plus 7 equals to 8. Hence, we have summation of 0 to 7 equals to e to the power of j 2 pi over n. We have summation of n to the power n equals to 0 to 7 e times e to the power of j 2 pi n. Since e to the power of j 2 pi n will always be 1, we have ck equals to 8. For k not equals to 7, we have the summation of coefficient equals to 0. So now we have discrete time Fourier series of e to the power of j pi n over 4 can be denoted as a single impulse of amplitude 8 at k equals to 7. Now we can add both discrete time Fourier series of e to the power of j pi n over 4 plus discrete time Fourier series of e to the power of negative j pi n over 4. We get discrete time Fourier series of cosine pi n over 4 as two impulses. One has impulse at k, another one has impulse at k equals to equals to 1, another one has impulse at k equals to 7. To represent it in the frequency domain for omega 0 equals to pi over 4, we have impulse equals to impulse 1. For omega 7 pi over 4, we have impulse 7. We always use the range of omega 0 from 0 to 2 pi or negative pi to pi. If we take the range of negative pi to pi, we can get a discrete time Fourier series of two impulses at omega 0 equals to negative pi over 4 and omega 0 equals to pi over 4.